Hey, 7th grade, Mrs. Hedrick here. It is May 13th. This is Math 7. We're going to make a jump into Lesson 26. So we're going to spend a little bit of time doing some statistics and probability before the end of the year. Lesson 26 is a short lesson to begin with, and I'm going to try and squeeze it all in, okay? So today we're actually going to work on 2 sets of pages. It's a lot of reading, actually. There's not a lot of mathematics that we're going to solve, okay? So today's lesson is about understanding random samples. So what is a random sample? So read along with me. You might want to grab a highlighter. Okay. How can you use samples to get information about a population? A food service company supplies meals for 12 different schools. How might the company get information about the students' favorite lunches? Okay, so this company is providing lunches to 12 schools, and they want to know, what do the kids like best? They could survey every student in the school, but that would take a lot of time and effort. So they're right, 12 schools. It would be more efficient to survey a random sample. That represents the whole group. So a random sample is a representation. It represents the whole. It's not the whole group. It's part of the group, okay? The population is the whole group, okay? So random sample is part of the group, and the population is the whole group. Okay, just a couple of notes. Now, the thing about random is that everybody has to have an equal chance of being selected. Okay, so we'll talk more about that. Okay? All right, let's keep reading. Each rectangle below contains circles, squares, circles, and triangles. The rectangle on the left shows that they are scattered randomly. The rectangle on the right shows them somewhat grouped, right? They're grouped. The circle in each rectangle represents the sample. So here's a sample and here's a sample. Well, if I look at this sample, I see some triangles, I see some squares, and a circle. If I look at this one, I don't see any squares. So which one of these do you think is random? A sample that selects items from an evenly distributed group is more likely to represent the population. So this one is closer to being a representation of the population. If you look over here, you automatically left a group out. So this one isn't as random. A sample that looks at groups from a sorted or an uneven mix may not represent the population. Okay, so this would be a better sample than this. And you can see why. This has a little bit of everything. This one doesn't have any squares. All right, let's keep going. How do you find a random sample for a population? In order for a sample to be considered random, every object has to have an equal chance of being selected. So I'm going to highlight that. I'm going to just do random. Every object or event has an equal chance of being selected. That's important. Everybody's got an equal chance. Look at the picture of the jar, which contains the names of students at Center School. Okay, so these are all the kids at the school. Maybe they're going to draw for a prize. Okay, let's read about it. Suppose you pick 10 slips of paper from the top of the jar. Do all the names have an equal chance of being selected? Well, no, right? If you're just picking from the top, maybe the slips at the top belong to the last class to put their names in the jar. Selecting from the top does not give the names at the bottom of the jar an equal chance, right? So there's not an equal chance. If I just reach in and pull the ones from the top, not every name has an equal chance. So that is a biased sample. It's a biased sample because it does not represent the whole population. So if you go back over here, this would be a biased sample. It doesn't represent everything that's out there. Okay? Suppose instead you put your hand in, right, and you mix all the slips around. You do this each time you pick 10 names. With this method, all the names would have an equal chance of being selected. So this would be a random sample. So you put your hand in the jar and you mix it all around and you pull out the names. If you're doing that, then you're going to get a random sample. Here are some other ways to represent a random sample. So use a pattern, such as selecting every 4th person who enters the cafeteria. So if I pick every 4th person, can I guarantee, like think of our cafeteria. So if I picked every 4th person who came in and asked them a question, would that be random? Sure, if I did everybody in the building. every fourth person. Use a method such as drawing names out of a hat where everyone has an equal chance of being selected. So if you go back to this, if every name is in here and I mix it up every time, then everybody has a chance of being selected, right? It need to be the same pieces of paper, same size. Divide the population into groups such as grade level and randomly select people from each group. So I've seen kids do this at St. Cecilia. Let's say they're doing a survey and they say, we'll pick 5 random kids from kindergarten and 5 random kids from first grade and 5 random kids from second grade. You could do that just as long as they're randomly selected, not like the first 5 alphabetically. Here are some ways of selecting that might result in biased samples. So these aren't good. Letting people volunteer to take a survey. So when you take volunteers, you automatically get a certain group of people. So you're going to only get their opinions. Choose people who are easy to reach, such as students who happen to already be in the cafeteria when you're available to give surveys. So this could be like one grade level, so you miss all the other people. Choose people as a group, such as students on honor roll. Well, duh. Yeah, if you just pick those kids, then you're not going to get a variety of opinions. Okay, how can you use data collected from random samples? So what do you do with it once you have a random sample? You can use data from a random sample to generalize about a population. Maybe half of the students in the sample say that pizza is their favorite lunch. You might predict that half of the population would give the same preference. The data collected from a sample might be used in making menu choices for determining food orders, right? They're not going to ask every kid in 12 schools. So maybe they randomly select, 100 kids from each school. And then if half of those kids like pizza, then maybe they assume half of every student likes pizza. All right, let's do the reflect question. What do you think would be a good way to select a random sample of students at the 12 schools in the school district mentioned? So how could they get a random sample? Maybe they select 100 kids randomly from each school. Maybe they select every 10th person who walks into the cafeteria. Yeah, let's do that one. Maybe they survey every 10th person who comes into the cafeteria. Okay, we could do that. All right, let's keep rolling. Next page. Identifying random and biased samples. So now that we know what they are, let's see if we can point them out. Okay, Carla has a list of 720 students in her middle school. That's a big school, and that's just middle school. She writes the name of each student on a slip of paper and puts the slip in a box. She pulls 30 names from the box to decide who she will survey about an upcoming school election. Okay, how many students are in Carla's sample? So the sample is the part. So how many people is she going to sample? She's going to sample 30 names. And then what's the whole population? So this is the part, this is the whole. How many kids? Yeah, 720. What are the different attributes of students or different groups of students that should be represented in the sample? So what do I know about these kids? To get a random sample, we should have different grade levels. Okay, we should have different genders, right? Boys and girls. Maybe like different hobbies. So it could be the sports kids. We could have band kids. We could have kids in drama. Should I say hobbies? What do I call that? I'll call it hobbies, but you know what I mean. Different likes, get a variety of kids. Okay. A graphing calculator or a spreadsheet or the computer, right? Can't you do random number selects on the computer? So they're going to create a list of random numbers. So it was a computer who generated this list of numbers. Describe one way you could use this list of numbers to choose the students from the school. So if there's 720 kids in the entire school building and I have these random numbers, what could I do? You could do like an ABC roster of the whole school, couldn't you? I'm sure there's a computer program to do that. So you could list every kid in order from an ABC order and then pick the 12th kid, the 92nd kid, the 584th kid, the 121st kid, the 35th student, okay? So you could assign each student a number. Okay, and then use those students. Would that be random, do you think? Sure, right? Because I have no idea what numbers are going to pop up. And if I put my kids in alphabetical order and I use those numbers, then certainly that's very random. Okay, does using random numbers generated by a calculator to decide who gets the survey, to who to survey, oh my gosh, let me read that again. Does using random numbers generated by a calculator to decide who to survey give everyone in the population an equal chance? Why or not? Does this give everybody an equal chance? Yeah, we just said that. Yes, it does, right? Everyone has a chance of being selected. That's the important part. If everyone didn't have selected, if everyone didn't have an equal chance, then it would be biased. But this is pretty good. Okay, no more questions to think about. Carla wants to ask whether students would be in favor of voting in the election by sending a text message to a specific number. So she asks students to text her a response. All the responses are in favor, so she generalizes that all students would be in favor of voting by text message. Is this conclusion biased? What do you think? Was that random? She says to kids, hey, just text me and let me know what you think. Was that a random sample? Nope. This is biased. Why is it biased? Because she's asking people to text her if they would like to text. So she's already getting kids who don't mind using their phone. What if they don't have a phone? What if their phone's broken? What if they don't have any data? What if they don't have any minutes? Okay, so you can write all that down. I'm not going to write all that down. Okay, let's keep going. All right, let's see what we think about this one. One of Carla's friends suggests that she makes a sample, the sample larger and survey 100 students. Okay, so go back to this original problem. So she picked 30 out of 720. So she has a friend who says, why don't you pick 100 students? Is the sample size of Carla's initial, or Carla's initial sample size of 30 more likely to represent the population? So which one's a better number to use? Should she pick 100 students or 30 students? Well, obviously, 100 would give you a better sample. 100 students would be a better sample. Does that make sense? The more kids you select, the closer you're going to get to the actual number, right? If there's 720 kids and you sample 400, then you're really going to get an accurate sample. If there are 720 kids and you sample 30, yeah, you know, it might not be as close to the population. So the more that you can sample, the better. All right, now, sorry, work with your group to decide if the methods for selecting a sample are fair or biased and give your reasons. I'm sorry. You get to listen to me talk about it. 8 says, Jacob is surveying students about their favorite subject. Okay. He asks 10 students who are playing basketball after school. So maybe he walks outside or walks into the gym and there's kids playing basketball. 8 of the kids say that gym is their favorite subject. Casey says that the results show that students who play basketball like gym best. Jacob says that the sample is too small to draw conclusions. So who is correct? Casey says, yep, students who play basketball like gym. And Jacob says, wait, that's way too small. All right, I don't know about you, but this feels biased, don't you think? If you're asking kids who play gym or play basketball what their favorite subject is, and you only ask 10, I don't think that you have a big enough sample. So Jacob is actually correct. There's probably more than 10 kids who play basketball, so they need to ask more kids who play basketball. Okay, how about number 9? A store owner wants to survey customers about the products that he sells. He programs the computer to select 100 customers from the mailing list and sends them each the survey. Okay, what do you guys think? Is this fair or biased? Computer selects 10 customers from the mailing list and he mails those people the survey. Yes, this is definitely fair. And why is it fair? Because every person has a chance of being selected. Up here, did every basketball player have a chance of being selected? No, just the 10 that he saw. So this is fair because everybody's on the mailing list, so everybody gets a chance. Okay, now homework is different tonight. Your homework isn't going to be in the book. I want you to do the iReady. So you're going to go do the iReady teacher assigned lesson. Guess what it's on? Random sampling. Okay. All right, my friends. I'll see you soon. Bye.